During a standard operating period, a corporate general ledger absorbs massive volumes of raw, unallocated costs. Materials are purchased, payroll is processed, and utilities are consumed, all simultaneously. Attempting to track these thousands of distinct expenditures across a sprawling enterprise without a structural system creates immediate analytical chaos. The core objective of all cost accounting is to impose order on this environment, to achieve the precise ascertainment of cost. To calculate this mathematically, the system requires a terminal denominator. The business needs a specific measurement device to break total expenditures down into manageable, attributable subdivisions. The formal accounting term for this essential denominator is the cost unit. The Chartered Institute of Management Accountants, or CIMA, defines it directly: a unit of product or service in relation to which costs are ascertained. This definition focuses strictly on relationships. It demands that accumulated costs must be directly linked to the specific end product manufactured or the service rendered. The GAAP framework offers a second definition: a form of measurement of volume of production of a product or a service. This GAAP document serves as the official preface and guiding philosophy for the broader cost accounting standards. These definitions arrive at the exact same functional requirement. Whether you view it as a specific relationship to a product or a measurement of production volume, the application is identical. Selecting the correct, highly specific cost unit is the foundational step in building a ledger. Until this denominator is defined, no complex cost accumulation or allocation can begin. Once the definition is set, we have to look at the physical flow of costs through an organization's accounting architecture. Expenditures take one of two distinct structural pathways to ultimately reach their assigned cost unit. This flowchart illustrates the first route. Pathway 1 represents cleanly identifiable expenses. Items like direct materials and direct labor are easily quantified. Their monetary value is traced and charged straight to the end unit. The complexity arises in Pathway 2. Indirect costs like facility rent or administrative overhead cannot be logically traced to a single manufactured product. Because they lack a direct relationship, these indirect costs must be routed through intermediary accumulation nodes called cost centers. A cost center functions as a specific department where indirect costs are gathered and heavily analyzed. This initiates the final mathematical step. The cost center divides its accumulated pool of indirect overhead into standardized fractions to be absorbed by the product. Without this rigorous analysis at the center level, establishing a true, accurate cost per unit is impossible. Cost units and cost centers are separate mechanisms in the ledger, but they are inherently linked to execute this allocation process. Regardless of whether an expenditure travels the immediate direct pathway or routes through the intermediary cost center, all accumulated costs must ultimately terminate at the cost unit. This raises a practical question. How does an organization decide what physical shape or metric their terminal cost unit should take? The selection follows a strict principle. Cost units are adopted entirely based on operational convenience and established practice within a specific industry. This grid maps out the standard choices across sectors.
In power generation, the output is continuous energy. Utilities logically require energy-based, volumetric denominators. They measure output by the megawatt or the kilowatt hour. Contrast this with the heavy manufacturing sector, specifically cement production. Bulk physical goods require straightforward, mass-based units like the metric ton to accurately measure total production volume. Discrete manufacturing and professional services require different approaches entirely to track their volume. An automobile plant counts distinct raw physical units, the number of vehicles produced. An audit firm measures its output in increments of professional time, billing by the chargeable hour. All four of these examples share a unifying characteristic. They are single variable measurements, tracking exactly one dimension of output: energy, mass, discrete quantity, or time. For tangible goods or strictly linear professional services, a single variable metric is completely sufficient to capture the true volume of production. Single variable measurement systems break down when applied to complex, non-linear service industries. Many modern services are intangible. Their operational costs are driven by multiple independent variables simultaneously, making a simple unit metric mathematically inadequate. The global logistics and heavy goods transport industry provides the prime real-world example of this exact multidimensional complexity. Delivery services face an immediate accounting dilemma. Their operating costs depend heavily on both the sheer quantity of goods carried and the geographic distance those goods travel. Which single variable should serve as the unit? Choosing only the physical weight of the cargo ignores the fuel and time costs required to cross the distance. Choosing only the distance traveled ignores the constraints and expenses of a heavy payload. This coordinate plane illustrates the mathematical solution mandated by GACAP and CIMA. The first vector captures the physical payload of the truck, measured in tons. The second vector operates simultaneously to capture the distance of the travel duration, measured in kilometers. Together, these vectors create a new structural denominator, the composite cost unit. A composite unit is a bipartite measurement. It mathematically binds two separate cost drivers into a single functional measurement to capture the total scope of the service. Implementing this composite approach is the only way to standardize cost measurement across delivery routes that vary wildly in both load size and geographic length. This bipartite structure applies across major service sectors. This data table details the variables used in healthcare and hospitality. A hospital requires a specific capacity metric, a patient, combined with a time duration metric, a day. Only by multiplying patient by day can administrators accurately ascertain the total cost of care. This complex math is a sharp contrast to the simple single-variable metric ton of cement, showing the necessary evolution of the accounting framework as business operations scale. The integrity of an entire cost accounting system rests entirely on the fidelity of its denominator. Whether an organization uses a simple single-variable unit or a multidimensional composite, the chosen metric must perfectly mirror the operational reality of the business. If the metric fails to capture that reality, the final cost ascertainment fails with it.